Unit 31, Geometric Tolerances, Location and Form. The previous unit, Geometric Tolerances and Datums, discussed the basic symbols and terminology used in geometric dimensioning. This unit provides a greater understanding of each characteristics of how that tolerances are identified. Modifiers. Symbols called modifiers are used to indicate the tolerances requirements apply when a part feature is at size conditional of size. The maximum material condition of a part exists when a feature contains the maximum material allowed. An example is a pin or shaft at its high limit dimension, or a slot or hole at its lowest limit. Figure 31.1, maximum material condition is specified by a modifier symbol M. It is also abbreviated with the letters MMC. The MMC applies when one or two or more features are interrelated with respect to location or form. For example, a hole and an edge, or two holes, and so on. At least of the related feature is to be one of size. 2. The feature to which the MMC applies must be a feature of size, for example, a hole, slot, or pin with an axis. So the shaft is going to be the largest size, and then a hole is going to be the smallest size on maximum material condition. So it's going to be whichever one weighs the most. Whereas least material condition is going to be whichever one weighs the least. So the smallest of the shaft or the biggest of the hole. It is also abbreviated with the L symbol, or LMC. Alright, regardless of feature size, or RFS, the regardless of feature size symbol is no longer required on industrial drawings. However, it may still be found on various prints or may be used in some companies. RFS is a condition where the tolerance of form or position must be met regardless of where the feature lies within the size or tolerance. The modifier symbol for RFS is S. When the modifiers are specified on a drawing, they appear in the same box and to the right of the tolerance. So, maximum material condition on that one. Alright, tolerances of form, profile, and orientation specify the allowable variation of geometric shape of the part feature. Form tolerances specify the allowable variation from perfect form as shown in figure and on the print, figure 31.4. Form tolerances are critical to part interchangeability. So, form tolerances. So it can't be wavy more than 5 thou on that one. It can't be. It's got to be within that zone. It's got to be roundness. It's going to have to be like that. And cylindrical, or centricity, it's going to be like that. So flatness is the condition of having all elements of a surface on one plane. Figure 31.4, the tolerances for flatness is identified as the dimensional area formed by two flat planes. The entire surface of the feature, including variations, must fall in this zone. Straightness is the difference in flatness, is different than flatness and should not be confused. Straightness refers to an element of a surface being in a straight line. Figure 31.4b. The tolerance for straightness specifies a zone of uniform width along the length of the feature. All points of the feature as measured along the line must fall within that zone. So roundness or cylindrical. Roundness is a condition where each circular element of each surface is at an equal distance from the center. Figure 31.4c, the tolerance zone is formed by two concentric circles. The actual surface elements must lie between these two circles at any place of the cross section. Then you got cylindricity, or however you say it, is the condition where the elements of a surface of revolution form a cylinder. The tolerance zone is specified or defined by two concentric cylinders along the length of the feature. Figure 31.4d, all points of the part feature must fall between these two cylinders. So you got profile tolerances. They're used to control the shape of arc, part contour, or irregular surfaces. Geometric tolerances symbols may specify each profile control of a line or profile control of an entire surface. Profile of a line The profile of a line is a feature profile as measured along a line. Figure 31.5a is the tolerance of the profile as a variation of the perfect form. All points along the feature must fall between the parallel lines of a perfect profile. And then you got profile of a surface. The profile of a surface is much like the profile of a line. However, the definition is broadened to cover the entire feature surface. 31.5b, all points of the feature surface must fall within the tolerance zone of the perfect profile. Orientation tolerances. They are used to control part surfaces, individual elements of parts, and part size features. Orientation tolerances specify requirements of parallelism, perpendicularity, and angularity. Orientation tolerances are always related to a datum. So parallelism refers to the surface line or axis that is equal distance from a datum plane or axis at all points. 31.6a, the tolerance zone specified is defined by two planes parallel to the datum plane. It may also be defined as a cylindrical tolerance zone parallel to the datum's axis. Then you got perpendicularity is the condition where the feature is 90 degrees from the datum plane or axis. 31.6b, all points of a feature surface must fall within the zone formed by two planes perpendicular to the datum. Runout tolerances specify the allowable variation of perfect form or orientation as described by the print. The two runout tolerances symbols are total runout or circular runout. Runout tolerances are always related to the datum. Circular runout is the deviation of the part feature at any measuring position when rotated 360 degrees on the datum surface or axis. 31.7a, a dial indicator is used to read runout of a feature. The tolerance zone is formed by two coaxial circles within which the total feature runout it must fall. So total runout is the deviation of the entire surface at any measuring point within the specified tolerance zone, made up of two coaxial cylinders when rotated 360 degrees on a datum axis. Location tolerances specify allowable variation in a location of a part feature in relation to another feature or datum. The two geometric tolerances symbols used to specify location are position and concentricity. Location tolerances must always involve at least one size feature or frequently apply the MMC modifier to maximize the interchangeability of parts. So position or true position is the term applied to the exact perfect location of the feature. True position is located with references to one or more datums. The position tolerances is the maximum amount of variation allowed. For true position, the amount of permissible tolerances is called as a tolerance zone. For cylindrical features, the zone is a diameter within the axis of the feature must lie. So concentricity refers to the condition of two features sharing a common axis. An example would be a step shaft where two diameters share a common center line. 31.ab, the concentricity tolerances is a diameter of concentricity zone within a feature of size a feature axis must be. Review of symbology is in the following questions. Use the information in each statement to create the correct datums. Okay, so we're not going to actually do that, and then here is your assignment that we're going to be doing.